Hi, and welcome back. Lesson 24, Fractions, Decimals, and Order of Operations. Let's begin with a lovely little recipe here for writing fractions as decimals. To write a fraction as a decimal, simply divide the numerator by the denominator. If you need to see that happen, we're about to dive into an example here. Write the following fractions as decimals. Do not use a calculator. Okay, let's grab the first one here, 3/5. Well, the recipe says to divide the denominator into the numerator. Aha! So I have to take 5 into 3.0. 3 means 3.0, right? So I'm going to write 3 as 3.0 so that I can perform that decimal division, because 5 doesn't go into 3, right? Or you could say 5 goes into 3 0 times. Line up the decimal. Then how many times does 5 go into 30? Aha! 6 times. So, long story short, 3/5 is equivalent to 0.6, or you can just say 0.6. And later, when we talk about percentages, this is going to make complete sense, because if you say 3 out of 5 people like that movie, turns out that means 60%. Turns out that means 0.6, which is 60%. And that makes sense, because 60% is a majority, and 3 out of 5 is a majority. So we're very soon in our near future going to be looking at this as majority minority type thing. All right, let's try again. 2/3 as a decimal. Well, I'm going to have to take 3 into 2.0. Because a lot of people say, how are you going to take a big number into a small number? Well, you're going to perform decimal division. So 3 doesn't go into 2, so I'll put a 0, line up the decimal, but 3 does go into 20 about 6 times, right? And then we start to get this sort of repeating action as we've seen before. 3 goes into 20 6 times, and we start to see we're going to get this 0.66666. So now we know that that's 0.6 repeater. And by the way, we're not supposed to use a calculator, but I do want to remind you that I could take, so 2 divided by 3, I could hit 2 divided by 3 on the calculator, and it says 0.666 repeater. So I could just check my answer, but I want to make sure I can do it by hand. Okay, and the last one, 1/8. Well, I'm going to have to take 8 into 1.0. And again, 8 doesn't go into 1. I'll line up the decimal. 8 goes into 10 about once. And then 1 times 8, is 8. Draw the line and subtract. You can bring down a trailing 0. 8 into 20 about 2 times, right? And then 2 times 8 makes 16. Draw the line and subtract. You can bring down another trailing 0. And 8 into 40, aha, 5 times. And there's where we terminate. There's where the decimal terminates. So from there on out, it's going to be zeros. So 0.125. So the decimal equivalent there is 0.125 for 1/8. I'll circle that. Okay. Now, just for grins and giggles, we've done this before, but I want to keep it fresh in the mind. Let's go the other way. Let's go from decimal to fraction. So from fraction to decimal, you have to divide the bottom into the top. Let's go the other way. Remember that when you're going from decimal to fraction, sort of the recipe there is to lean off of the place value chart. So I'm just going to say here, use place value. All right, tenths, hundredths, thousandths. Aha, so that's 45 thousandths. So I'm just going to write that as 45 thousandths over 1,000. And, reduction is fine. So note to self, reduce that. So let me write this here. 0.045 is the same as 45 out of 1,000, which we know is going to reduce. 5 goes into 45 9 times, and 5 goes into that 200 times, and voila. And I always like to check it later on the calculator, so after I've done it. So 0.045 and then this lovely button, math, frac. Most calculators have that. See, 9 out of 200. But see, I'm only doing that after I've done it by hand. Okay. And then 3.02, again, lean off of the place value, tenths, hundredths. So that's read as 3 and 200ths, which is a mixed number. 3 and 200ths. So that's a mixed number, and we can convert the note to self. We can convert the mixed number to an improper fraction. So 100 times 3 is 300 plus 2. So we could say that's 302 out of 100. And heck, we could even reduce that down, right? So, and in fact, I wanted to mention that if you were to do this on the calculator, if you were to hit 3.02 and then hit math frac, notice it gives you 151 out of 50. Well, notice 151 over 50 is just the reduced version of 302. Just divide by 2 on top and bottom. Okay, so that's good practice with the sort of going back and forth between fraction and decimal form. Now let's look at comparing fractions and decimals. General recipe, general strategy to compare decimals and fractions. Write the fraction as an equivalent decimal. So if somebody says compare 0.125 to 1/4, unless I know in my mind that 1/4 is 0.25, I have to physically perform that division. So I'll take 4 going into 1.0. That's an easy fraction. Most people know it, but I can still do it. So 4 goes into 10 twice. Draw the line and subtract. Bring down a trailing 0. 4 into 20 goes 5. And now I see that terminates. So I see my 0.25. So what I'm really doing is saying, okay, 0.125 blank, I'm going to leave that blank, 0.25. And when you say compare, that means insert greater than, less than, or equal to symbol. So I think of money, 0.125 is really close to 13 cents, and 13 cents is definitely less than 25 cents, so less than. Make sure you know, note to self, make sure you know the symbols, that's your less than symbol. I've seen people literally write the words in is less than until you get comfortable with those symbols. Again, compare 3/8 to 0.38. Well, I've got to grab 3/8 and convert it. So I'm going to take 8 into, unless I naturally know what that is, some people do, line up the decimal. 8 into 30 goes about 3 times. Draw the line and subtract. Bring down a trailing 0. 8 into 60 goes about 7 times. So a lot of this relies on knowing our times tables, right? 60 minus 56, that's 4. I can bring down a trailing 0. And 8 goes into 40 5 times. So there's where it's going to terminate and become zeros on out. So 0.375, so we really have 0.375 blank 0.38. So, I mean, you might say that rounded, that's close to 38 cents, which is true. It's close to 38 cents, but it's definitely less. 0.375 is less than 0.38. And if you're doing the digit by digit comparison, 3 matches with 3, but 7 is less than 8. So you need a less than symbol. All right, hope that helps. Let's see what we have on the next slide. Order of operations we've done already in this course. Please excuse my dear Aunt Sally. I'll let you read through that, but I'm going to dive headfirst into this example. So you want to take care of your parentheses and your exponents first. So 2.2 and 3.1, you might be looking at that and adding it in your head and saying that it's 5.3, and that's great. If you do need to go off on the side, I was going to say, if you do need to go off in the margin, always go off in the margin, you know, if you're going to perform operations, so it doesn't mess up the flow of your writing. So that's 3, that's 5, so it's 5.3. I'm going to keep all the connectors. And then same thing here. I want to go off on the margin to take care of negative 2.3 squared. Squaring means times by itself. So I'm going to go off in the margin and figure out what, now it's a negative times a negative, so you know it's going to be positive. So I'm going to figure out what 2.3 times 2.3 is. 9. 3 times 2 is 6. 0, 6, 4. And that's 9. So we're looking at 529, but we'll keep the decimal back 2 places behind the decimal, 1, 2. So we're looking at 5.29. And like I said, if you take a negative, it's inside the parentheses and you square it, it's going to be positive. So you can take care of that in your mind. So now here's the kicker. We have 5.29 plus 4.1 times 5.3. How are these two connected? They're connected by multiplication. And see, the thing is, when you think about PEMDAS, multiplication dominates addition. You've got to take care of that first. So now you go off on the side and you think about what 4.1 times 5.3 is. And that's 3. That's 12. It's always just kind of do all that stuff off on the margin so it doesn't mess your flow up over here. 0. 1 times 5 is 5. 5 times 4 is 20. Luckily I have an eraser so I can kind of erase some of this other work. 5 times 1 is 5. 5 times 4 is 20. 3, 7, 1, 2, and 2 behind the decimal. So 21.73. So here we have 21.73, and then we have 5.29, and then adding to that. So that final frontier where we're going to add these two, we'll do that. I'll hit pause. We'll do that off on the side. Excuse the ambulance in the background if you hear it. I'm doing this out in my sunroom, and there's must be an accident out there. So like I said, I don't like to mess up the flow of my order of operations problem. So I always go off on the side and do that marginal, that work off in the margin. So 5.29 plus 21.73, I just do that off in the margin. And voila, we end up at 27.02, which was the final answer. Okay. And a lovely another example. I think that might be, let me double check. Yep. Until we move, that'll be our last one on this page, and then we go to the next slide. Absolute value, I know people get rusty, so negative 4.2 minus 8. You know, let's play mental math. I want you to start thinking about money. So if I have a loss of 4.2, so $4.20, right? And I lose another 8, guess what? I'm going to be out $12.20. So you can think about that in your mind, or you can go off on the side and take care of that. But let's do that. Plus 3.1 squared minus 1.25. Now remember that PEMDAS says to take care of your grouping symbols first, like your brackets, your bars, anything like that. So absolute value of negative 12.2 is clearly going to turn that positive 12.2. Then I'd like to take care of my exponents, so I'll go off on the side and do that. 3.1 squared, I'm going to have to figure out what 3.1 times itself is. So that's going to be 961. So 9.61. Okay. So 9.61. And then eventually minus 1.25. Now, here's the fun part. When you boil your problem down to just addition and subtraction, you may move left to right. So you can move left to right over addition and subtraction. So you might want to do, again, off on the margin, you might want to do 12.2 and then line that up with 9.61, you know, and add that first. So 21.81. And then eventually deduct the 125. So now I'm going to deduct the 125. And careful though, because that's subtraction. So 1, I cannot take away 5, so I'm going to borrow from the 8, turn that into a 7, turn that into an 11, so that'll be a 6. Line up the decimal, 1 minus 1, nothing, and then bring down the 2. So after all that sweat equity, 20.56. So you can do a lot of that sort of addition and subtraction off in the margin so it doesn't mess up your flow. Okay? Now what I like to do is double check my math. After I've done it by hand, I like to double check it. So, you know, I'll key it in, negative 4.2 minus 8. I got something, negative 12.2, but then I turn it positive because of the absolute value. And then I can double check it. So plus 3.1 squared is something. Oh, sorry. 12 at this part here. So let's try that again. So 12.2, because I'm turning it positive. So 12.2 plus 3.1 squared is something. 21.81. And then minus the 1.25. 20.56. And voila, we got it. Okay? So just, again, just check it after you've done it by hand. Now, one with a lovely fraction mixed in there. If you see fractions and decimals mixed together, just change your fraction to a decimal. So we know 1/2 really means 0.5. So we have 0.5 times 3.2 minus 6. So you might be able to do this mentally if you're thinking about money, like $3.20, lose $6. But if you actually want to write it out, take the bigger number minus the smaller number, but know that the bigger number is negative, so that's what's powering it, so you're going to get a negative result. So long story short, let's take 6 minus 3.2. We can call that 6.0. You would kind of do the same thing if it was money, right? So that's 8. So that's 2.8, but it's going to be negative because the bigger number is negative. So negative 2.8. And then you want to multiply that with 0.5. So again, you can do that off on the margin. I'll scoot this next one down. 2.8 times 0.5. And I know it's a positive times a negative is a negative, so I usually take care of the sign and then feed in the result. So let's see, we're multiplying there. So 0, carry the 4, and that's 14. And then 2 spots behind the decimal, so 1.4. But again, it's going to be negative 1.4. Okay? So that's going to be your final answer. And again, let's talk about just checking it on the calculator. Okay? So 3.2 minus 6, so force myself to do it by hand and then check it. And then times, I could say times 1/2 like this, or I could say times 0.5. Negative 1.4. So by the way, negative 1.40 and negative 1.4, I can say it either way. Is acceptable. And I believe, is this our last? Yep, that's our last one for today. Evaluate the expression. We have x minus 2y plus 3z, and we're given, it says evaluate this for given input. Well, input, that's just like plug and chug, right? And then you end up doing order of operations. So we end up with x is 0.24, right? So 0.24 minus 2, plug in your y guy, that's 3.8, plus 3, connected with multiplication, plug in your z guy, which is negative 0.02. See, and once you've written that out, you're really right back to order of ops, okay? And that says that you have to take care of multiplication first. And again, I would just do that off on the margin somewhere. Don't let that mess you up. So, you know, 3.8 times 2, that's going to be 7.6. So That's going to lead me to 7.6 there. The rest of it I'm going to carry down. And whatever 3 times 0.02 is, which you can probably do in your head, is 0.06. But it's a positive times a negative, so it's going to end up negative. Okay. When you arrive here, I would think about money. So 24 cents, lose $7.60, lose another 6 cents. You know, just think about loss and gain. But some people say maybe you should pin the losses together first. And style-wise, that's up to you. You could do that. I think it's just as fine to move left to right. So if I have 24 cents and I lose 7.60, I better take the bigger number, so 7.60, minus the smaller number. But just know that the answer is going to be negative because the bigger number is negative. So we'll borrow from him. So that's going to be 736, but negative. So negative 7.36 and then minus 0.06. And if you're really good with money and change, you can probably do some of this in your head. So if I have a loss of $7.36 and I lose another 6 cents, what would I be? I'd be in the hole, right? Negative 7.42. All right. But like I said, if you need to go off on the side and write that out, a negative, lose 0.06, you're really kind of taking those two amounts and adding them together. And then the answer takes that sign because it's like signs. So 7.36 really plus another loss of 6 cents. So that's where we're getting that loss of 7.42. But again, just to track it, I would go up to the original. So I would do 0.24 when we first up here, when we first had those input. So I'd do 0.24 minus, and then I would just key that in, 2 times 3.8. I'd key it all in. And then plus, paren, 3 times, what was it, negative 0.02. Just to check. And I'm arriving at negative 7.42. And voila, that's what we got. So I know that takes a lot of practice. And you may want to just kind of rehash these on your own, hit pause. Let's see. Yep, that's the end of our guided notes, and wish you luck out there.